it's an honor to be here, to be talking to you. I'm Toby, I'm from the GNOME project, and I want to talk about how I think that GNOME is in a good position to deliver the next secure operating system for the users. I've brought a few slides, probably too many, especially given that we have a bit of a delay due to the technical difficulties involved with setting up a GNU Linux system with projectors. It's been a bit of a fight, but finally we've managed to make it work. So I'll probably have to go over my slides a little bit more, a little bit faster than I should. I hope that's okay with you. Of course, I will hang around, so if you want to discuss any of these things that I will present, then please do approach me and say hi. I usually don't bite. Sometimes it happens, but most of the time it doesn't, so you're safe. So the title is Security is Dead, Long Live Security. And what I want to talk about is how I think that we need to rethink how to architect security and presenting it to the user. I think that, traditionally, the way we've presented security mechanisms to the user, they could be better, because I think we have so many good security technologies and security solutions, but we're not making good use of that, and essentially users tend to, disable those security features as soon as they get in the way. And I want to present a few examples of how I think this is, hindering us from getting a more secure operating system, and I'll have some examples you're going to see. So I'm from the GNOME project, as I've said. Let me quickly talk about what I believe GNOME is and what, the philosophy behind GNOME is, why GNOME exists, what it wants to achieve. It wants to be very inclusive in terms of user base. So GNOME wants to be the operating system for, pretty much anybody that has to do computing. It's not necessarily meant for being, or it wants to have the biggest user base possible and making computing as easy as possible without getting in the way, so that soft term user experience, the GNOME people define it as making your computing, the least awful. So we believe that you are sitting in front of the computer, not because you like sitting in front of the computer. I mean, some of us do, admittedly. But at the end of the day, you have a task to perform. At the end of the day, you need to get something done. So you're sitting on your machine, not because you're necessarily sitting, in your basement with the window blinds shielding the sun off, and you're staring into the computer screen. You usually have to do something most of the time. And we try to enable you to do that as efficiently as possible without the, operating system getting in your way. So in order to do that, to reach many users, we go to great length to make it accessible in terms of language also. So we have many translations. The GNOME desktop, the GNOME system is available in many languages. And we also try to include people that cannot use the computer in, say, ordinary ways. So we try to be accessible for people that have disabilities or are otherwise incapable of using the regular or normal interfacing methods for the computer. And of course, the GNOME project started out back in the day to protect the user's freedom. The freedom was the essential part why GNOME existed in the first place, because if you recall history, then you will notice that the GNOME project was founded because there were no free alternatives for the desktop system. Freedom also means that you're free from your computing being compromised. We want the user to be free of, having to fear that whatever they do can be compromised, be it that somebody else reads what you're writing in your text document, or being that you don't want your results to be, compromised by a third party when you're not sitting in your computer, for example. So we want to protect you from threats that exists out there. Turns out the internet is a very bad place, these days at least, so there's a lot of things to protect from. And I'm not claiming that we are protecting against all the threats there are, but we try to make your computing as safe and secure as possible. And I think GNOME is in a good position to do that, because as it turns out, that filtering out extraneous information is the main reason for us to exist. So our brain does nothing else but filtering out information, because there's so much information reaching our brain, we would be unable to do anything if we were not filtering out most of what we get into our brain. So why am I saying this? I'm saying this because we ought to try to filter extraneous information before it reaches the user. We should try to act in a way that the user expects, without, going on the user's nerves, without telling the user, do you really, for example, do you really want to, I don't know, perform this action now? Hell yes, I've just pressed this button. What do you think I want to do? Like, we ought to filter out the user's intent. We ought to get to know what the user wants and then act accordingly. And for security systems, this is especially true. If the security system involves the user, then the user can make a bad decision. And we don't want bad decisions to happen, right? We want the computing to be performed as securely as possible. And if there's a chance of making a wrong decision, then, well, that's bad. And it turns out there have been experiments. There have been scientific experiments with users making security-relevant decisions, and it turned out that drawing a coin, tossing a coin, was much more accurate than letting the user make the decision. So you could, instead of asking the user what they want to do, you could instead toss a coin, and you'd have more accurate results than letting the user decide. Because users, they want to get their job done, right? If you are sitting in front of the computer and get a job done, and then you're being asked something stupid that the user, say, has never heard before and doesn't understand, then they try their best. They go to great length to work on their task again. And if you're showing a dialogue, then they do their best to get rid of this dialogue, no matter what it takes and what it means. And I think GNOME, so far, has been doing well in this regard, in trying to, well, not annoy the user with things that, well, are deemed to be irrelevant in this context. So my main message is, if you're taking one thing away from this, then it shall be that prompts are dubious. Prompts are modal dialogues that interrupt you while you're working, while you are at your task, doing your thing, and then the system kicks you out of your mind and asks you something that's unexpected for you. We shall not do that. We shall avoid these things as much as possible. Security-relevant things are just wrong, because if the user is in the middle of performing a task and then, well, annoying the user with this decision that has to be made now, the likelihood of a wrong decision increases in that instance, because the user just wants to get back to their task, right? And if this security decision that you're making is permanent, you may remember this, please remember my decision tick box on these modal dialogues. That's just evil, because then there's no way of the user ever amending this decision. There's no way the user could ever come back to this place and, well, decide otherwise. So we must try to avoid these things as much as possible. Then you may ask, well, how do we do that? And turns out you can design user interaction in a way that gets rid of these dialogues. And there's many instances where you can see that. The one way of doing things is to allow failures and allow them to be undone. So in your text editor, we all are used to undo, the undo function, and it's conceivable that such an undo function can be used more widely in our ecosystem, so that you allow for errors to be made, but allow the user to recover from them if it was indeed a mistake. So I've brought a few examples, and this is a little bit of a shaming session, but it's very, very fast also. So this is a connection dialog, right? So in this case, the chat application. So you start the application, you want to chat now. This is why you start the application. And then you're greeted with a relatively technical window, and then you have the option of canceling or pressing continue. And the user has just opened that application, right? Of course they want to continue. Why on earth would they have pressed this, why on earth would they have started the application in the first place? And we probably know what that means, because we're technical people, so we can interpret this information on the screen. But if we want to be inclusive in terms of user base, then we need to assume that this information is useless to most of our users. So, of course, I claim the user will press continue because they don't know what to make out of this dialogue. And we've seen this before. I mean, this sort of dialogue has been popular 3 to 5 years ago, so we've all seen this. There's other more or less funny dialogues. This is a software installation center or something, and the dialog says, this software is not signed by a trusted provider. Do not update this package unless you're sure it's safe to do so. And I imagine, the average user that I imagine, how would they even assert whether something is trusted, let alone safe to do so? I don't think we can expect our users to make that decision for us. And imagine the case where someone pressed the update button in that software center. Of course they want to install this now. That's why they've pressed this button. So why on earth do we even ask the question whether they really want to do that? We ought to find better ways to interact with the user to get to know the user's intent and act accordingly. And this is one of my favorites. Albert found a problem. Please execute pkcon update dash dash repo dash enable equals Fedora, and so on and so on and so on. And then you have the option of yes or no. What? Why do we even show this dialogue? What does it do? What's the purpose of this dialogue? And of course, as you can see, it's been a while. This is from Fedora 17. Now we're at 28, so this is it's been a while. Fortunately, we are doing better now. But it still shows that well, we also think about the user interaction, how we perform our interaction with the users. So, point is, try to avoid forcing the user into making a decision they don't know anything about. And there's this law attributed to Allison. He made it like 15, 20 years ago at a Usenix security conference. It basically says, whenever your security system requires interaction with the user, let it be a click or something to type, then your user base declines by half. So imagine for every click that you need to do, right, for everything that you need to type, every single keystroke reduces your user base by half because the users simply don't know what they're doing. Tossing a coin would be more efficient than letting the user do this decision. So, who of you can guess what this is? Has anybody ever seen this? Key signing, exactly. So you see, what do we see? We see a bunch of people. In this case, it's 220 people. That was FASTM 2011 or so. FASTM, by the way, is the biggest European free software open source conference. I highly recommend going. It's taking place in winter, though, in February, early February. So these people are standing out in the cold. And I guess Brussels in winter is not as awful as Kiev is in winter. So it's probably only 5 degrees Celsius plus rather than minus 40 as here in Kiev. But it's still, for Europeans, this is still bad, right? And these people queue there outside for probably 2 hours or something, or 3 hours. And what do these people do? Someone said key signing. What do these people do?
They exchange keys, so security keys.
Right, they're exchanging keys. How do they do that?
They say, I am this and this person, and here's my key.
Right. So they say, I'm this and this person, and here's my key. And here's this key means 40 hexadecimal characters. So they mumble, you know, this awkward fingerprint to each other, like this. So this is 160 bits of information encoded as base 16. Let me ask you, what's the least efficient way of encoding 160 bit? Like, if you have several encoding schemes, how would you know, which one would you choose if you were to make the least efficient choice? Binary. You would probably choose 0 and 1 for your 160 bits. What's the second least efficient way? Octal, right? You would probably use some octal scheme. And then, maybe not the least efficient, maybe not the second least efficient, but the third least efficient way of encoding this information is base 16. And people are doing this for 20 years. People have actively chosen to use this very inefficient encoding for transferring 160 bits of information for 3 hours in the cold in Brussels in winter every year. And I think we can try to do better. Because we have several problems with this scheme, right? If we have this basic scene encoding, then we get some visual problems distinguishing the characters and all. And then once you've exchanged the keys, what do you do? You're the expert there. What do you do once you've exchanged the keys?
You use them.
Yeah, you don't use them yet, right? You have to sign them first. How do you sign them? How do you sign these keys? So people tend to use CAF. CAF is a good software. It's like a big Perl script. It's a nice piece of software. You configure it using raw Perl, though. So in order to use the software, you have to learn Perl. You have to know how to program Perl. I mean, admittedly, it's not that hard, right? Every donkey can program Perl because it accepts everything. So it's not that hard. But if you want to do something meaningful, then you need to learn like the syntax and everything. And this is how you do this key signing stuff. You have to stand for 3 hours in the cold. You have to, utter these 160 bits of information in a very inefficient way, and then you have to use Perl in order to put it all together. And I mean, Jesus, what is this? It's 2018, right? Are we doing this? Has anybody, is there a big evil plan to, prevent the big security thing by having us use base16 and Perl, and the infrastructure uses OCaml? That's this weird French programming dialect from the 1600s. Is there some force behind that prevents us from, being nice and secure on the internet? Probably not. But still, let's try to be better. Let's try to, let's try to be a little less awful, just a little bit, so that maybe, my parents could do the whole key signing thing, that they don't need to be experts in the field of cryptography and security. So I think there's no big evil plan. I think free software people have just scratched their own itch. And, technical people scratching their own itch leads to probably technical solutions, which is fine, which is a good thing to do. But if we want to, get the next order of magnitude of users, we have to think of these users and target them instead of ourselves. Okay, so now I've ranted so much, right? And now people say, oh, come on, Toby, provide solutions, not only complain. Complaining is easy, do something about it. I say, okay, so let's imagine how we could make the process less awful. How about we have a window where we can select our key? How about we have then some information that allows for transferring this key to another person? And how about on the other side, we have some form of receiving window, and then we could scan this information, and then we've transferred the key, and then we press one more button, and then we are done. Wouldn't that be cool? Yes, you have to say yes, that would be so cool. We've been waiting for this our whole lives. And there we are. I mean, I think we can design this process, which has been awful for 15 years, in a way that allows more users to, be comfortable with this process and allow them to be more securely, to do their computing more securely on the internet. And yeah, this is a software, it exists. It's called GNOME KeySign, and I wanted to show it not only because it's one of my pet peeve projects, and I want you all to use this project, but also because I believe that it shows how we can make people a little bit more secure by thinking about how the user would perceive, this process, in this case, this key signing process, and then trying to design for these kind of users. So yeah, that's one thing. Another thing, I'm coming with a few case studies here. I've planned for 3 case studies. That was the first one. Now I'm talking about the containerization stuff, and then if we have some time, I want to talk about some USB, protecting against rogue USB devices. So now we've seen one instance of how we can make the user more secure by providing nice interfaces and user interaction. So the next big thing within the GNOME project is containerization of apps. So we all know this from your mobile phone operating systems, that the apps do not, or are not allowed by default at least, to touch the other applications files, for example. It's quite restrictive, and you have the feeling that you are in relatively tight control over what the app is doing and accessing, right? You've all seen these pop-ups coming. Do you want this application to allow, to read your location, for example? We all know this. On the Linux desktop, so far, this has been hard. It still is. But we're trying to get there that you can exercise more control over the applications that you're running and what they are allowed to do. So we try to containerize the applications and isolate them from each other and from the operating system. And yeah, we do that with technology that's called Flatpak. And then you might say, oh, why don't you just use Docker, right? Everybody loves Docker. It's 2018, everybody uses Docker. And you have a few challenges with that. First and foremost, the security system, the permission system, doesn't allow for runtime decisions to be made, at least not in its current state. So you might appreciate being able to, let an application share your location or share the location with your application for the next, 15 minutes. And you would then need to revoke access after that time has passed. Or you want to allow access to, say, print a document, but only whenever you press the print functionality. You don't want to expose access to your printers all the time. In fact, you might not want to expose access to printers at all. You might want to have a sort of a proxy that, such that the application doesn't access the printers at all times, but only through the proxy. And so these things make it challenging, at least, to use existing, say, Docker things. That is not to say that it doesn't exist. People have packaged up X11 applications in a Docker thing and run them and all. It's just wrong, though. So Flatpak. Flatpak, at the end of the day, is two things, as containers are. Containers are bundling your applications, that you have one file, maybe, that you can transfer and then install and run. And the other part of containerization is isolation. So the bundling part is done with OS3. It's like Git for binaries, if you want to, call it that. It's a content addressable storage, and you can transfer files quite efficiently with that. And the other part, the isolation part, is done by bubble wrap. It's essentially setting up a sandbox on Linux using all cool technologies like user namespaces, and you have these runtime permissions and everything. So that's cool. Then we can isolate the apps from each other because we have relatively tight control over what they're allowed to do. But then we still want to access, say, our documents. Because if we're installing, say, LibreOffice, we still want to interact with the files on the host, right? Because if you're only using LibreOffice in isolation, that's not much fun. That's pretty useless, actually. So what we need to do is we need to punch holes into the sandbox in order to allow the application to interact with the host. And we can do this statically, or in some instances we need to do this statically. Say if we wanted to access devices, like, your graphics adapter maybe. Or if you wanted to reuse the virtualization capabilities of your host, then you need to grant access to these devices statically. But we do have so-called portals which allow for dynamic or runtime holes into this sandbox. So we can relatively fine-grained give or take access to certain parts of the host operating system. That's quite cool. And that means that you can open files from your host without the application running in the sandbox knowing about anything else but this one file. That's actually quite cool if you think about it. So your application cannot steal your data. Your calculator program cannot steal your emails if the calculator is being exploited. Because all the calculator will ever see, if anything, is that one file that you've selected and not your whole home directory. That's quite cool technology, actually. So Flatpak is getting more and more popular, and by now we have, I actually haven't counted, but there's many apps already packaged as a Flatpak, and that exists today also. And with this technology, we allow for, the user to do their computing more securely because, as I've said, if one application is being, hijacked, being exploited, then it doesn't necessarily have access to all the rest of your host operating system. So that's quite good. These are the portals. You can imagine there's a file chooser. You see in the top middle column, you see the file chooser, and all the application running in the sandbox will ever see is this one file that you've selected, nothing about the rest of the host system, for example. And in the lower right corner, you have this print dialog, and the application all the application will ever see is that it's now printing something, but it doesn't know where to, or let alone which printer model and these kind of things. So that's a really cool thing. The last case study I want to present is concerning USB security. So my machine is standing there right now, and I have no idea what it's doing. Right? I'm not present at my machine. It's actually it's locked, and there's no reason that it does anything via USB because it's, how could I ever plug something in because I'm not present? The machine is locked. I'm away. Yet, if you plug anything into the USB port, then Linux will happily talk to the device. Linux will happily load any driver that the device tells Linux to do. And it turns out there's a lot of drivers in this current GNU Linux operating systems. And it turns out you can program USB devices very cheaply to be whatever they want. And the quality of the drivers of certain USB devices is questionable at best. So we have this large attack surface sitting there waiting, to be exploited for no good reason, because it doesn't. The argument is that it doesn't make sense for the operating system to load any driver while you're not even present at this machine. You can make this argument, and there's few instances where it does make sense to do so. But for most cases, my argument is that we should not load any random driver off the disk when somebody's plugging in a device when we're not even present at the machine. And it gets worse because USB, there's a USB IP driver. So worst comes to worst, you don't even need physical access. You can do that remotely in the worst case. So the questions to ask is, like, if you wanted to protect from this threat, so we're building an operating system, we're GNOME right now, and we want to protect against, some random dude putting in a USB pen drive or USB device, and then my kernel loading weird drivers, and then the device interacting with these drivers. So what questions do we ask ourselves now? I would say that we need to find out when do we use USB, and more importantly, when do we not? And we need to find out who else uses the USB when we don't even know about it. And we need to find out, in which state we are as a system, and then act accordingly. So USB is dangerous. It's being pointed out that my time is running out. So there's a lot of USB issues. It is an issue. I'm not making this up. I have a wild fantasy, admittedly, but this is not necessarily a fantastic thing. It does exist. People do exploit things via USB. And turns out that Linux can indeed stop USB from, being talked to. So we can indeed stop USB devices from having access to the kernel, say. And this is prototypical now. So the first two things were real software that exists, and this is now more future work, what we could or should do. So Linux allows for blocking certain devices on certain ports. We have all the infrastructure ready. Now we need to tangle it up. We need to wire it up to the operating system, to the desktop, to make this decision as to when to block the whole USB stuff and when not to block. And one simple case could be to just lock the USB down when the screen is locked. That would be the trivial thing to do. And we're not there yet. While we have the options of doing so, there is no logic that actually does it yet. And I think we need to investigate some brain power into finding out, when to actually do the whole locking thing and when to unlock. So I have a few more demo videos of how this could work, but I skipped that in the interest of the schedule, and also to keep something for the discussion for later when we are in the hallway. And with that, I want to thank you very much for your attention. I know it's been a bit fast from my side, but I think we still have some time for questions if there are any. In that case, thank you very much anyway.
Yeah, we really have a little bit time for questions. У нас есть совсем чуть-чуть времени на вопросы. Вопрос? Just a moment. Maybe I'll go there with my microphone. Your question?
Hi, thank you. And my question is, why do you have to put all dependencies in your container? They are duplicated in the system, and the space isn't a piece of rubber.
Why do we put what in the system?
Dependencies, all the dependencies
okay.
for application.
All right. So this is a twofold argument. One is you want to have the application bundle, you want this to work. So the if you wouldn't bundle up all your dependencies, then you would somehow need to provide these for the application, right? And then you would need the host operating system to have all those weird dependencies. And that's actually what we're having now. Like status quo is that you, if you want to install some applications, right now you need to provide all the dependencies. And this turns out to be complicated for some people. But, so you are, from what you've said, you seem to be worried about the space. The space is not an issue though, because OS3, the way OS3 works, is it deduplicates these files if they exist anywhere else. So it's a non-issue. Your concern is not valid here because OS3 takes care about that. So if you have two applications using the same library, the very same library, then it exists only once on the disk because of the way of how OS3 works. It's like the Git of large binaries. So it's a non-issue. The other part of that question is that common libraries or common dependencies are shipped in their own, say, bundle. So Flatpak has this concept of two images that you have to provide. One is the so-called runtime, and the other is the application bundle itself. And common libraries like GTK, for example, or OpenSSL maybe, actually, I don't know. But some common libraries are in the runtime, or are supposed to be in the runtime. So you don't have to provide this with your application image, because you expect that to be present in the runtime already. But yeah, it's a good question.
One more question.
Sure.
The library was not duplicated, but usable by all the Flatpak applications. For example, if I pack OpenSSL library into my Flatpak, and other Flatpak have also the OpenSSL library, it will be shared between the Flatpaks, yeah?
So the question is whether a customly built OpenSSL, for example, will then be shared by other apps which are Flatpaked.
I pack some malware, for example, into my OpenSSL and back into the Flatpak. Will other applications share my malware OpenSSL?
Right, and in particular, if I put some malware into my library, will other Flatpaks pick it up? The answer is no. Because the way OS3 works is it basically hashes your file, and then addresses the file by the hash. And if you provide another file, it will have a different hash, and then other Flatpaks will not see it because they still require like the original thing. So yeah, that's an okay thing. And yes, if you were able to compile the same library bit by bit, the very same way as the other applications, then yes, you will share these files. Turns out, though, in practice, we are not there yet to have reproducible builds. We're working towards having that, but the likelihood of you compiling to the very same bit-by-bit binary as the other image is still low, too low. We need to address this, though. We need to work on reproducible builds. But that's the story for a whole other talk. There maybe? All right, I couldn't understand so well because you were talking not loud enough. How about we discuss this in the break? Approach me.
Ross.
Because I think we're being shut off now. All right, thank you again for your attention. It's been a pleasure, and I'm looking forward to be talking to you.